Governed AI is not just a policy exercise. It needs an architecture that connects risk decisions, technical controls, lifecycle management, monitoring, and evidence. In this module, we'll use a reference blueprint to make ISO IEC 42001 expectations practical for real AI systems. We've already built the foundation: what ISO IEC 42001 expects, how AI governance is scoped, and how risk, accountability, policy, and compliance fit together. Now we move from requirements to implementation, translating governance concepts into a practical architecture for data, models, controls, monitoring, and human oversight. Without a governed reference architecture, each AI project tends to invent its own rules. That leads to inconsistency, hidden risk, and weak audit evidence. A shared architecture turns governance into design by connecting business value, technical controls, risk treatment, and certification readiness from the start. A governed AI system is easier to manage when we treat it as a stack of responsibilities, not as a single model. At the top, business process and user experience define where people interact and what outcomes matter. Application and model services turn those needs into AI-enabled decisions or recommendations. Orchestration coordinates prompts, tools, workflows, and approvals. Data pipelines and infrastructure provide reliable movement, processing, scale, and resilience. Across every layer, monitoring, security, and governance create evidence, traceability, and control. That is how architecture becomes accountable, not just functional. Governance starts by anchoring the model in the actual business process. Map where work begins, where AI contributes, who receives the output, and which decisions affect someone's outcome. Then define the human layer: operators, reviewers, accountable owners, affected users, and escalation paths. The user experience should make AI involvement visible, including confidence, limitations, and required actions. Approvals, overrides, appeals, and feedback also need to be captured. These records support oversight, incident review, and continuous improvement, so governance becomes part of daily work rather than an add-on after deployment. Think of this layer as the operating system for enterprise AI. Application services are where users and business processes access AI through APIs, apps, workflows, or decision services. Model services make AI consumable by packaging models, prompts, embeddings, endpoints, and metadata behind controlled interfaces. Orchestration coordinates the sequence: retrieve context, prepare inputs, call the model, process outputs, and route exceptions to human review. The key principle is runtime control. Every request should be authorized, validated, filtered, rate-limited, logged, and monitored before AI becomes an operational service. AI systems depend on two foundations working together: trusted data flow and reliable platform operations. The data pipeline moves raw sources through ingestion, processing, feature engineering, validation, labeling, and continuous quality monitoring. That creates datasets teams can trust. The infrastructure layer provides compute, storage, environments, and deployment services with clear separation between development, testing, staging, and production. This separation reduces accidental change and supports controlled releases. Just as important, every step should be traceable, from source data to training set to model version to inference result and finally to the operational decision. Monitoring, security, and governance act as control planes across the full architecture. Monitoring shows what is happening: performance, latency, failures, drift, bias, usage, and whether the business outcome is still acceptable. Security controls who and what can act, using identity, access, encryption, secrets, network protection, and vulnerability management. Governance preserves the decision record: approvals, risks, control mappings, exceptions, audit trails, and lifecycle status. The principle is integration by design. These services should not be manual afterthoughts. They should continuously enforce policy, detect issues, and preserve evidence. Governance becomes practical when it is built into the AI lifecycle as a series of control points. A use case should not move forward just because a team is technically ready. It moves forward when the right inputs are complete, accountable reviewers approve, acceptance criteria are met, and evidence is captured. This applies from intake and data approval through training, validation, deployment, monitoring, incidents, and retirement. Wherever possible, these gates should be workflow-enabled or automated, so pass, hold, and escalation decisions are traceable to risk, policy, and ISO IEC 4200 expectations. Before an AI initiative enters delivery, governance should answer two questions. Is the use case well defined, and is the data appropriate to use? Intake captures the business purpose, capability type, users, affected stakeholders, decision criticality, and regulatory exposure. Risk screening tests impact, sensitivity, autonomy, complexity, and possible harm. Data approval confirms lawful basis, ownership, consent or usage rights, quality, representativeness, privacy, and security constraints. The result is an approval record linking the use case, risk rating, data sources, and accountable business owner. During the build stage, control starts before training begins. The team should have approval for the dataset, model objective, training setup, and accountable technical owner. Once training starts, the environment must make experiments traceable and repeatable, with version code, data, parameters, dependencies, and access controls. The validation gate then tests whether the model is fit for its intended use, not just whether it scores well. It checks performance, robustness, fairness, explainability, security, privacy, and operational readiness. The output is evidence: reports, model cards, risk updates, exceptions, and a clear go or no-go decision. Operational control begins before release. Deployment approval confirms that validation is complete, risks are accepted, rollback is ready, monitoring is configured, and ownership is clear. Once live, the system must be watched continuously for performance, drift, unusual usage, security events, fairness signals, and user feedback. If something goes wrong, teams need a practiced path: detect, triage, contain, analyze root cause, notify stakeholders, correct the issue, and preserve evidence. Significant change loops back through validation. Retirement is controlled as well, including decommissioning, retention, communication, archiving, and transition to a replacement. The goal is to make evidence a byproduct of running the AI system, not a scramble before an audit. As data pipelines, controls, models, approvals, tests, monitoring, and incidents operate, they should automatically create records: logs, decisions, metrics, model cards, lineage, and risk updates. Each record needs context. Who approved it? When was it created? Which dataset, model version, control, or release does it relate to? When records are tamper-resistant and centrally retained, certification readiness becomes continuous. Auditors can trace governance through the system's normal history, rather than through reconstructed narratives. For ISO IEC 42001, architecture decisions need a clear chain of accountability. Start with requirements, risks, and governance policies. Translate them into objectives, risk treatments, policies, and concrete control measures. Then link each control to the AI components it affects, the owners responsible for it, and the records that prove it is working. The traceability matrix is the practical tool here. It shows whether controls are implemented, monitored, reviewed, and auditable. This makes governance explainable, not only for model outputs, but also for the decisions behind system design and operation. The main takeaway is that governed AI is not a single control or document. It is an architecture, layered services, lifecycle gates, and evidence flows working together. When these patterns are built in from intake through retirement, organizations gain auditability, accountability, and certification readiness. Next, we deepen the foundation with AI data governance, model lifecycle, Gen AI controls, and oversight.